And today we are in section 5.4, and now we're going to write our own proportions, and we're also going to solve other proportions, okay? So we're going to look at three methods for solving a proportion. We actually already touched on this just a little bit yesterday. To solve a proportion using mental math, all right? And we know with mental math, we have to find what we are going to call a missing link, okay? A missing link between the sides of the ratio that we know, all right? So look at the proportion. Do you see on the bottom part of the ratio we know both sides? 2 and 8, you see how we know both sides? Okay, so I'm just going to look for the missing link that could get me multiplication or division that could get me from a 2 to an 8. What could I multiply 2 by to get to 8? 4, okay? So if I'm going a smaller number to a larger number, that would be multiplication. 2 times 4 is 8. So 3 times 4 is x equals 12. Okay? What I also want you to see, and you might see this on your homework, if I'm going from the bigger number to the smaller number, I would divide. I can also divide to go the other way. Do you agree that 8 divided by 4 is 2? Yes. So if I have to go from the bigger number over to the smaller number, then I would simply divide by the missing link. All right? Do you see how it can work both ways? Yes. Okay? So on the next one, I want you to work together in your groups, figure out what the missing link is, and solve for D. Go ahead and work together on that. All right, so what's my missing link, guys? 4 is my missing link, okay? All right, so because I'm going from the smaller number to the bigger number, do you agree I'm multiplying? Yes. And the same thing, could I divide 20 divided by 4 to get down to the smaller one? Yes. So 8 times 4 is what? 32. D equals 32. And, guys, there's an easy way you can check this. 5 over 8 equals 20 over 32. You could still do your cross products, and you would see that 160 equals 160. All right, so you could plug it back in and make sure they equal each other. This part is optional. You don't have to, okay? But there is a way to check it. Any questions on mental math? All right, so here, my challenge to you would be this on your homework. If you see a clear connection, mental math is way faster than cross products. Cross products will still work, but if you can catch this, you can do your problems faster, which that's kind of nice. The homework won't take as long. Okay? We have another method called multiplication. With multiplication, the variable must be in the numerator. Okay, if it's not in the numerator, this method doesn't work. So for these first two methods, it seems like there's always this like, well, it only works if this, right? It doesn't work 100% of the time. All right, so on this one, the variable has to be in the numerator, which I see on both of them. X and W are both in my numerators. I'm going to solve this like I would solve an equation, okay? Where I would multiply by the reciprocal, okay? I'd multiply by the reciprocal. So whatever is connected to X, what number is connected to X? 21. I would multiply both sides by that number. So when I multiply by 21, I got X by itself, but now I have to multiply 5 over 7 times 21 over 1. Okay. Could I maybe cross reduce to make that easier? Yes. 7 and 21. Cross reduces to a what? 15 equals X. All right. Kalani, how are you doing on this? Doing okay? I want you guys to work in your groups and do the second one. All right, you must use multiplication. Don't use mental math. Well, mental math, there's not even a connection anyway. Well, there sort of is, but it's not a whole number. Okay, what number is connected to W? 6. So I would multiply both sides by 6 over 1 times 6 over 1. Did anybody cross reduce? Yeah. Okay. 6 and 9. 2 and 3. Okay, but now when I multiply, I got W equals 12 over 3. Is that my final answer? W equals 4. W equals 4. Who got 4? Who got 4, guys? Raise them. All right, good. Okay, well, 12 over 3 is not 4. You got to reduce it. You got to reduce it. Okay. Yes, Hadley. 12 divided by 3 is 4. So 6 times 2, let me backtrack. 6 times 2 is 12. And then, yeah, gotcha. Okay, all right, great question. Any other questions? Anything else, guys? All right. Okay, so I'm kind of sensing that we're getting this. Is that the right? Yeah. Okay. All right, step 3, cross products. This is a method that we started to kind of learn yesterday when we were testing. Now, or when we were testing to see if there were proportions. Now there's something I'm solving for, but I'm still going to do cross products, 10 times x and 8 times 7. So what's 10 times x? What's 10 times x, Hadley? 10x. And then 7 times 8, class? Class? 56. Okay, now, what would I do? Hope, what would I do to solve for x? Divide by? Divide by 10. Okay? Divide by 10. And x equals, does anybody know the easy way to divide something by 10? Without having to do, not add decimals. Move the decimal. Yes, Addie. Which way would I move my decimal? Left how many places? Yes, because every power of 10 stands for 1 decimal place. So if I'm dividing by 10, I would simply move my decimal left 1 place. It would be 5.6. So what if I were dividing by 100? Move it 2 places. Move it 2 left. Okay, so but in this case it was just 5.6. All right, what do you see that's different on this next one?
There's a plus 1.
There's an m plus 1. All right, now I still do, this is definitely an example of when cross products is the only one that works. Okay, so m plus 1, I still do my cross products in multiplying that by 15, but now look what it looks like. Because I can't do m plus 1, but I know I have to multiply it by 15, equals 6 times 40. So now my cross products turn into, starts with a D, distributive. Turns into distributive property. 15 times m is 15 times 1 is equals, do y'all know the easy mental math here? 6 times 4, 24, add the 0. Okay? So anytime you're multiplying by those multiples of 10, that's what you can do. So 24 and then add your 0. All right, now I want you to finish solving the equation. So a distributive property, it turns into a 2-step equation. Subtract 15 from both sides. 15m equals 225. Divide by 15, and ironically, m equals what?
15.
15 again. Okay, 15 again. All right, who got 15? Raise your hand. Good. All right, yesterday. Oh, wait, I'm not there yet. I'm getting ahead of myself. Okay, well, you know, this still applies to what we did yesterday. Now I need to write my own proportion. They're written as ratios, and I need to write my own proportion. So the way I'm going to do that is by putting these ratios into fractions. I need to put these ratios into fractions. Okay, so 3:8 would be 3/8. X to 20 would be x over 20. And now you will have the choice, just on your homework and on your quiz and on your test, you will have the choice as to which method you want to use. I'm going to kind of push you in the direction of cross products, okay? If you can pick up on the mental math part and there's an easy connection, do that one, all right? But cross products works every time with no exceptions. Go ahead and solve for x on both of these. Write them as proportions and solve for x. All right, so now we have 8x equals 60. Divide both sides by 8. X equals 7.5. Raise your hand if you got 7.5. Did you get 7.5? All right, now on the next one, 2/4 equals x over 6. Okay, so just do your cross products. 4x equals 12, x equals 3. Now, I had someone point something out on this one, so I want to highlight it, although I want you to do the steps. You might think it's tedious to show these steps, but I promise you, and I think you've already seen in chapter 4, these equations can get pretty yucky, can't they? Right? That's maybe the right word for it. They can get real complicated. 2/4 can be reduced to what? It's 1/2. Okay? So the fraction that would make x over 6 1/2 would be 3/6, and that is still the same answer. However, you are going to be asked on your homework, on your quiz, and on your test. We are practicing proportions. You're going to be asked what method you used. Is that a method? No. You're just winging it. And we know that winging it works sometimes, but it doesn't necessarily work every time. That's only going to work if there's some kind of an equivalent ratio to follow. Okay? All right, example 5. All right, a chef increases the amounts of ingredients. Now, we talked about this. Yeah, just flip the page. I think we're... Okay, did you find it? Okay, I'll give you a minute to find it in your notes. Are you ready? Are you ready to listen?
Yes.
Okay. A chef increases the amounts of ingredients in a recipe to make a proportional recipe. We talked about this. As soon as we find the value of the ratio, we can scale it. We talked about it with the cups of flour and the flubber. I think it was flubber in that example. You guys remember that? Is that kind of ringing a bell? So as soon as we know the scale or the value of the ratio, we can make it bigger. That's what's happening here. This is the part that may not be fully clear. This is my original recipe. So now let's read the scenario. The new recipe has 6 cups of black beans. Which proportion can be used to find the number of cups of water in the new recipe? What I want you to do first is I want you, with your pencil, okay, to cross out the information in the recipe that would not be relevant to this problem. I want you to cross out the information that would not be relevant. What you're going to find is sometimes you have information in these problems that you actually don't need to answer what it's asking for. Okay, does it say anything about salsa?
No.
Does it say anything about the tomato or the seasoning?
No.
Okay, so from the original recipe, okay, I'm definitely going to need black beans because that's in the new recipe ratio, and I'm going to need water. So now I need to put that into a ratio, and let me tell you this, guys, it doesn't matter which way you go with it. I could say 1.5 over 2 or 2 over 1.5. I'm going to go black beans, which is 1.5, over water, which is 2. Beans over water equals, now for my new recipe, where do you think 6 would go? In the numerator or in the denominator? Based on what I told you yesterday. Beans over water equals Beans over water. So 6 is which one? Beans or water? 6 is beans over water, which I don't know. Okay? Do you see how I did that? If I do beans over water on one ratio, I have to match it up on the other side. You may need to go back tonight and watch this part of the video if that's not quite clicking right. That's okay. You can fast forward it. So now that I know that, guess what? I can cross product. Actually, I don't even have to solve it yet. I forgot we have options over here. All it wants to know is A, B, C, or D, the ratio or the proportion I would use. Which one does this match with, A, B, C, or D? It's D, guys. Look, this ratio, this is 1.5 over 2 equals 6 over X. So here's what I'm saying. In order to choose the right one, you actually need to set up your own. You need to set up your own. Okay? Now, do you see how, all right, you really need to pay attention to this so it doesn't confuse you. Do you see how this on A is the exact flip? Okay? So on A, they did water over beans. Do you see that on A? But look on the other side. They did beans over water on the other side. Do you see that? They didn't compare the same unit on both sides for A. Look at B. Why is B wrong? Why is B wrong? Okay.
So they did beans in the water and then water over beans.
Did you hear Colin?
Yeah.
This was beans, right? 1.5 over water. But then on the other side, they did water over beans. They didn't compare the same unit on both sides. B will not work. B will not give you the right answer. What did they do wrong on C? This is a little different. Hadley? Okay, so they did, we'll call it the original, the OG, original beans over the new beans, but then they did new water over original water. If they had done originals over news, it still would have worked. There is not one way to set up a proportion. There's actually multiple ways. But do you see on A, B, and C how they were switching them? None of them matched on both sides. Okay? Only D did. That's why D was the right answer. If you can get that, you can do any of them. If you can understand that. I feel like I've got probably maybe like a 50-50 split on that right now. Hopefully we can get better. All right, let's go to the next example. Let's kind of like get a fresh start here. I want you to try to set up your proportion in your groups, work together without help from me, just kind of using that chef example. Okay, I'm just going to give you about 30 seconds to see if you can do it. Don't solve anything yet because we don't know if you set it up right. All right, guys, there are actually 4 ways that you could set up this proportion. Yes.
I mean, we all have different ones.
Okay, so here's what's important. Same units on both sides. Someone give me one way that you set up this proportion, Alexa.
I put 50 gallons over 2 heartbeats equals 1,000 gallons over X.
That's perfect. How many of you did this one? That's probably going to be the most common. All right. Does anybody have a different one? She did gallons over beats, heartbeats. Gallons over heartbeats. Addie?
I did 50 over 1,000.
She did 50 over 1,000 equals 2 over X. Okay, so let's look at this one. Okay, she did original gallons over the new gallons equals original heartbeats over the new heartbeats. Okay, so that actually would work. That actually would work. All right, any others? You could flip these two. That's the other 2 options. You could flip them. You could just say like flip it on its head, basically. So it could have been 2 over 50 and X over 1,000. I don't want to confuse you though. I just want to show you there are multiple ways to set this up. So on your cross products, 50x equals 2,000. Divide by 50. X equals what? 40. 40 what? 40 heartbeats, okay? As long as you compared the same unit on both sides, okay, and you had equivalent comparisons, you would have got 40. If I had done it the other way, do you see it would have been actually the same cross multiplication? It still would have been 2 times 1,000 and 50 times x. All right? It would have been. Okay, any questions, guys? Okay, I feel like y'all are kind of maxed out. Y'all okay? All right, we have homework tonight. We're gonna, that's it for today's lesson. We have homework tonight, 9 problems. And we also have test corrections to work on. So the first thing I need you to do is get out a blank sheet of paper. And that will actually wrap up everything we need to know for 5.4.